Integration of tangent x over cos x plus secant x. Replace this tangent x with sin x over cos x and secant x with 1 over cos x. Take the LCM in the denominator. We're left with cos square of x plus 1 over cos x. This denominator with this denominator can be cancelled out and we will get sin of x over cos square of x plus 1. Now let cos of x equals to t. Then differentiating both sides will give minus sin of x dx is equals to dt. Sin of x dx, this minus sign if moved on the right side will get sin of x dx is equals to minus dt. Now sin of x dx is minus dt. Cos square of x will be t square plus 1 as it is. Negative sign will be taken outside and integration of 1 over t square plus 1 dt is tangent inverse of t and t is cos of x. So we got minus tangent inverse of cos of x plus c. Question number 31. We have to integrate 1 over sine of x minus a, sine of x minus b. Now remember one thing, we are just expanding this function for getting some more functions so that we can easily simplify it. We know that if we have a minus b, if I write a minus b with minus x plus x, then this is the same thing because minus and x will be cancelled. Now I will combine this x with this b as x minus b and the rest of the things with minus sign as common like this. Now I am multiplying this whole fraction with sine of a minus b and sine of a minus b. I am multiplying it and dividing it with sine of a minus b. This sine of a minus b, in place of a minus b, I can write now x minus b minus x minus a, this thing. Now, we can use here a formula of sine alpha minus beta. Consider as this alpha and consider this beta. The formula for this is sine alpha cos beta minus cos alpha and sine of beta. It is of this, we can open this formula as like this. So sine of alpha minus beta can be written as sine of alpha cos of beta minus cos of alpha and sine of beta. Alpha, consider alpha as x minus b and beta as x minus a. Now we have two functions here with this negative sign. Just divide this denominator separately with both of them like this and separate the integral signs as well. Sine of x minus b will be cancelled with sine of x minus b. Sine of x minus a will be cancelled with sine of x minus a. Now cos x minus a over sine x minus a can be written as cot of x minus a and here as cot of x minus b. We know that the cot integration is ln sine that function. So integration of cot x minus a is ln sine x minus a and cot x minus b will give the integration as ln sine x minus b. ln has the property that we can write both the functions in one ln. If it has a negative sign, then we will write it in division form. So first function will be written in the numerator and the second function with the negative sign will be written in denominator like this. So this is the answer of this question number 31. Question number 32. Integrate tangent x ln secant x. Let t equals to ln secant x. Differentiate both sides. Ln secant x, derivative of ln secant x is 1 over secant x and the derivative of secant x is secant x tan x. Just simplify it, we will get tangent x dx. Replace the terms. Tangent x ln secant x is t and tangent x dx is dt. So integration will be t square by 2 and we know that t is ln secant x, so t square will be ln secant x whole square by 2. Question number 33. Integrate 1 over 3 tangent x plus 1 cos square of x. Let t equals to 3 tangent x plus 1. dt will be 3 is a constant coefficient. Tangent x has derivative secant square of x dx. Now in this integration we have dx over cos square of x. Just make secant square of x as 1 over cos square of x. Now we got this thing. This 3 is extra here, just move it on left side, we will get dt by 3. Now replace the values. 1 over t and this thing will give us dt by 3. Move this 3 outside, 1 over 3, and integration of 1 over t is ln t. Just put back the value of t here, we'll get this answer. Question number 34 says, integrate e raised to power sin x cos x, let t equals to sin of x and dt will be cos of x dx. So e raised to power sin x will be et and cos x dx is dt. Integration will be e raised to power t, that is equals to e raised to power sin of x. Question number 35. Integration of under root 1 plus 3 cos square of x. Let 1 plus 3 cos square of x is equals to 3. Just take the derivative on both sides. We will have minus 3 into 2 sin x cos x dx equals to dt. Now 2 sin x cos x can be written as sin 2x. We have sin 2x here. So we need only sin 2x dx. We don't need minus 3 here. So just move it on the right side. We'll get sin 2x dx equals to minus 1 over 3 dt. Just replace the values, take the constant term outside and integrate this term, power plus 1 divided by this whole power plus 1. Simplify it, t raised to power 3 by 2, and we will also get here 3 by 2. So if we move it up, just multiply it with 1 over 3, we will get 2 by 9. Now replace t with this value. We have t raised to power 3 by 2. Just write this t value and write the power 3 by 2 and plus c. Integrate sin 2x over 1 plus cos square of x. Let 1 plus cos square of x is equals to t. Take the derivative on both sides. Just make the possible terms like we have to replace it. Sin 2x, we need sin 2x here. So I have made it, converted it into sin 2x dx equals to minus dt. Replace the terms. This under root t, 1 over under root t has no integration formula. Just move it up. Make the power negative because it is moved upside. Now power plus 1 divided by this power plus 1. Simplify it. Replace the value of t here. We'll get this answer. Question number 37. 1 over 2 sin square of x plus 3 cos square of x. Just divide the numerator and with the denominator the term cos square of x. Both the terms, not only with the one term, because if we just divide it with only one term, this can change our integration. So just divide it with both so that it is of the same step if we go back. Okay, 1 over cos square of x can be written as secant square of x. 2 sin square of x over cos square of x can be written as 2 tangent square of x, and 3 cos square of x over cos square of x can be written as 3. Now let tangent of x is equals to t. Take the derivative on both sides and we get this value. Replace the terms here. Secant square of x dx will be dt 2t square plus 3. Now we have to make completing square method here. We can also use here this formula 1 over, we can make it like 1 over x square plus 1. It can be made like this formula. X square is t square here. We need here a square, but it is 3 by 2. We can write it like in this term, a square. So write it like under root 3 over 2 if it is not completing square. So we can write it in under root and then take the square. Now this is the formula for if we have integration of 1 over x square plus a square dx. It has the formula 1 over a tangent inverse x over a. A is under root 3 by 2. So 1 over under root 3 by 2 tangent inverse 3 over under root 3 by 2 plus c. Rearrange the terms. This is in denominator. It will move up, and the reciprocal, we will just take the reciprocal if we move it up, and this 2 by 3, this 3 by 2 will also become 2 by 3. Now we have to find the value of t, that is tangent x. So we write it like tangent inverse under root 2 by 3 tangent x. This can be solved as under root 2 over 2 will be equals to 1 over under root 2, because here this 2 is under root 2 under root 2. This will be cancelled, left behind 1 over under 2 into under root 3. Both will be multiplied because both are in under root. So it will be 1 over under root 6 tangent inverse under root 2 over 3 tangent x plus c. Question number 38. Integrate 1 over under root x secant under root x tangent under root x dx. Let under root x equals to u. Take the derivative on both sides. We will get this thing. Now 1 over under root x dx is equals to 2 du. 1 over under root x dx will be replaced with 2 du. Secant under root x tangent under root x will be secant u tangent u. We know that its integration is secant of u. So we got 2 secant of u plus c, and u is equals to under root of x. Question number 39. Pi raised to power sine of x plus sine of x raised to power pi into cos of x. Integrate both sides. Now let sine of x equals to t. Differentiate cos of x dx will be dt. So we'll get pi raised to power t plus this is t raised to power pi, and cos of x dx is dt. Separate the integral on both of this function. We know that this is like this, integration of a raised to power x dx. This is equals to a raised to power x over ln of a. So we'll get a raised to power t, that is pi raised to power t as it is, over ln of a. A here is pi, so we'll get ln pi plus this is the same as integration of x raised to power n, that is x raised to power n plus 1 over n plus 1. So it will be t raised to power pi plus 1 over pi plus 1 plus c. Replace the t with sine of x and we'll get this answer. Now the last question of this exercise is question number 40. Integrate cos of x over 3 sine x plus 4 under root sine of x. I have let sine of x equals to t square. Cos of x dx will give us 2t dt. So cos of x dx will give 2t dt. 3 sine of x will give 3t square. And 4 under root sine of x, under root t square will give 4t. Now I am taking this 2 common outside. Take t from the numerator and t from the denominator common and cancel both of the t from the numerator and from the denominator. I will left behind 1 over 3t plus 4 dt. Now this function, if you see 3t plus 4 has the derivative 3. If I make 3 here, I can then integrate it for the ln. So I am making 3 here by multiplying it with 3 and dividing it with 3. Now this function has the derivative in the numerator. So we can write it like ln 3t plus 4. And we know that t is equals to under root sine of x from here. T is equals to under root sine of x. So just replace t with under root sine of x. I hope you understand the exercise 4.2 very well. After 4.2, we will definitely do exercise 4.3.